So for grade 10, I have prepared this video on the week 3 learning that we had. Our learning objectives were to find out the midpoint of a segment on a coordinate plane and the length of it. Then we learned about the bisector theorem and its converse. We look into each of this, and we even solved a worksheet or application based questions on these two. So let's see, how do we find the segment midpoint. Suppose you have a line like this which is of 10 centimeter length. It starts with 0. It's easy to find out the midpoint. You know that it's an average. 0 plus 10 by 2 equal to 5. At the point 5 you will have your midpoint, right? If it's on a plain paper, it's easy to find the midpoint. But what we have to find or learn here is to know the midpoint of a line segment which you have on a coordinate plane. So what is a coordinate plane? You have your x-axis and the y-axis. Now you have two-dimensional segment over here. So you have learned to mark the axis. Suppose you have a segment like this. Now how do you find out the midpoint of this? There is a formula which is x1 plus x2 by 2 comma y1 plus y2 by 2, which gives us the midpoint of the segment. So for that, what is the first step? Step 1 will be to mark these coordinates. One could be x1 y1 and the other will be x2 y2. Okay, you put a small comma in between. This is how you mark the coordinates. So what is this x1? This point is 2 comma 1, and this one x2 y2 is what is on the x-axis. You have minus 1 on the x-axis and maybe minus 1 on the y-axis. Clear? So minus 1 comma minus 1. Now how do you find the midpoint? You write it all. x1 is equal to this one 2, x2 is equal to minus 1. Here x2 is minus 1. Then here y1 is equal to 1 and y2 is equal to minus 1. Now you just have to substitute each of these values in this formula to find out the midpoint. So why are we doing all this? If it was a straight line on a single dimension like this, okay, what do you have? You just have to find the average of these 2 points and you get the midpoint. Here it's actually an average that you're doing, but for the x points alone you have to take the average, and the y values alone you have to take the average and put a comma in between, because it's a midpoint will be a point over here which is an average of the x values and the y values. And now the second thing that we learned is to find the length. Length again you find using the formula root of x2 minus x1 the whole square plus y2 minus y1 the whole square. You just need to substitute these values over here. So what I found you making a mistake is on knowing that minus and minus is a plus. So that's where you're making a mistake. Minus x2 is minus 1 minus x1 the whole square plus y2 is minus 1 the whole square, right? y2 minus y1 the whole square. Now minus 1 minus 2 is root of minus 3 the whole square plus minus 1 is minus 2 the whole square. Now some of you don't know that minus 3 square is what? Minus 3 into minus 3. And minus 3 into minus 3. When you have 2 in minuses, it's plus 9. So you have 9 plus minus 2 into minus 2 will be 4. 10, 11, 12, 13. You have root of 13 as the answer. You can use a calculator to find out what the value is. And this will be the length of this particular segment. You can't measure it with a scale here. Suppose when does it become difficult to or not proper to measure it using a scale? Suppose your coordinate axis was like this, wherein this is 0 and you're marking this as 2, 4, 6. Now if you measure this, it's not going to be proper with the scale, because each unit is 2 centimeter over here. You have it over here as plus 2, plus 4. Okay, so what do? You mark the endpoints and then just substitute this formula. Now let's see what the perpendicular bisector theorem states. Now you use this symbol for perpendicular, you use this particular symbol for parallel. Okay, so if I want to say these two lines are parallel, this is line L and line M. How do I write? L is parallel to M. Now let me prove the theorem. So what is a theorem? A theorem is just a statement that I give without any evidence. So I'm just telling you a statement right now. What is the statement that I'm giving you? I have a line segment AB and this particular line CD is perpendicular to AB. Whenever it's perpendicular, I say that it's a 90 degree that it forms over here. Now, what is my perpendicular bisector theorem? Given CD is perpendicular to AB, right? Given CD is perpendicular to AB, any point P on the line will be of equal length to the endpoints. PA is going to be equal to PB, or you can use the symbol congruent. PA is congruent to PB. So suppose you measure this and find it as 4 centimeter. This is going to be 4 centimeter. If I have a point here, say point Q, now your QA is going to be equal to QB. If I have a point on the bisector S, SA is going to be equal to SB. If I have a point E, EA is equal to EB. This is what the bisector theorem says. So what does the converse of it say? The converse says that given, what is given over here? Given any point P and the length PA and PB to be equal. You have a line segment, given a point P, and it's given that PA and PB is equal. PA is equal to PB. So suppose they're telling you that this is 3 centimeter each. Now, if you have a point P where and the length to the end points are equal, then P is on the perpendicular bisector. This is what the converse say. So the perpendicular bisector theorem states that if CD is perpendicular to AB, and if you have any point on the bisector, the length till the endpoints is going to be the same. And the converse says, if the length is the same, then this point is on the bisector. Clear? So the bisector theorem states that any point if you have on the bisector, here we are not bothered, or we are not talking about the bisector right now. Here we talk about it. If you have a point on the bisector, the length till the endpoint will be the same. And here what do we say? If the length from a point to the endpoints of a line segment are the same, then this point is going to be on the bisector. P will be on the bisector. Suppose I have a point Q, and QA is 18 centimeter and QB is 15 centimeter. See, QA is 18 and QB is 15. What does this mean? Q is not on the bisector. Clear? So these are what we learned last week, and we had applied these theorems and the converse to solve some of the questions. So let's look at the worksheet that we solved. This is one of the questions that we did. If MO is the perpendicular bisector, MO is the bisector of LN. Okay. Now what do you have? This is a point on the bisector. In that case, OL will be equal to ON. What they have asked you to find is ON. So that will also be 8 centimeters. So you need to write, by the definition of perpendicular bisector theorem, ON is equal to 8 centimeter. I'm just rushing through it. We spent a lot of time in class 2 to solve them. So if you have any doubt, just go through these two. Now you have to find X. How do you find it? Now let's see what information you have. You have the line segment as YZ. See? YZ. And what do you have? You have 90 degree. So what does it mean? WX is the bisector. Now on WX you check what you have. You have a point W. So WZ is equal to WY. Why? Because by the perpendicular bisector theorem, any point on the bisector, if you take, the length till the endpoints is going to be same. So that means 2x plus 11 is equal to 4x minus 5. Now I bring all the x on one side, 4x minus 2x, and here I bring all the numbers to the other side. So some of you had a difficulty here too. When you bring any number from the right side to the left side, the negative 5 becomes a plus 5. Here what do? I bring the plus 2x from the left side to the right side. So plus 2x becomes a minus 2x. So 11 plus 5 is 16 is equal to 2x, and you get your x as 8. Read the question carefully. They ask you to find the length of the segment too. So how do you find the length? This is the segment. WZ and WY are two segments. So substitute your value 8 here. 2 into 8 plus 11 will give you the length of that segment. That is 16 plus 11 is 27. And substitute it here, you get the answer. If you substitute 8, you get it as 27 too. Now OQ is the perpendicular bisector, this one. OQ is the bisector of MP. Which line segments are equal? Because OQ is the bisector and Q is a point on the bisector. MQ will be congruent to QP. These two are given the same, right? So what did I tell you? By the converse of the bisector theorem, if the distance from a point to the end points of a line segment are equal, then this L is going to be on the bisector. Never judge a figure by the look of the figure, okay? Here don't use a scale and extend it and say that yeah, L is on the bisector. That's not the way to do it. The figure may not be on in scale, the measure could be different. So you need to prove or give your answers by looking at the values or the information that is given on it, not by extending a line or drawing it and finding out that it's on the line. Here, because the segment length is 15 and 15, by the converse of the theorem, L will be on the bisector. Okay, so L is going to be on the bisector. For this answer, yes, L is on OQ. Why? Because of the converse of the perpendicular bisector theorem. Now, how do you find x over here? You just equate it. 11 is equal to 4x plus 3. Why? Because of the bisector theorem. Now, you bring all the numbers on one side. Let the x be on one side. 11 minus 3 is 8 is equal to 4x, and you get x as 2. Clear? Now the same thing you find over here too. You equate x plus x is equal to 22. Now this is how a theorem proof looks like. So I had explained this too. The proof of the theorem, this is called a two-column proof. You have the statement written here and the reasons written here. Okay. So what is the first statement that you have? You always start with what is given. What is the bisector theorem? What do you know here? CD is perpendicular to AB. That's what you know here. CD is perpendicular to AB. So that is something that is given to you. So start with what is given to you. If CD is perpendicular to AB, you know that D will be the midpoint. Why? Because of definition of perpendicular bisector. Because you know, if you have a bisector, then D will be the midpoint. Now, if D is the midpoint, this AD and DB will be equal, right? AD is equal to DB. Why? Because of definition of midpoint, AD and DB will be equal. Now what do you have? CDA and CDB are right angles. What is the reason for you telling that these two are right angles? What is the reason? Again, definition of perpendicular bisector. Because it's a bisector, you know that these two will be 90 degrees. So that's the reason. Now angle CDA and CDB are congruent. Why? Because you know all right angles is equal to 90 degree, right? All right angles are congruent. Why? Because it's the same. All right angles, these two are going to be the same. It's congruent. The angles are same. What is the sixth one? So here this particular line is shared by both of them. So you can call it a reflection. This line is a reflection for both of the triangles. So CD is congruent to CD, which is the reflexive property. And you have these two triangles are congruent now. Why? Because of the SAS postulators, SAS congruence theorem. So what is this SAS? You had done your homework on this, on the different types of congruence. SAS means if two sides and an angle are the same, for two triangles, both the triangles are going to be the same. So AC is equal to CB. What is the reason for that? Because corresponding parts of the congruent triangles are congruent. Okay. So it's almost 13 minutes now. Revise all this and go through. Okay. Bye.